Hello everyone. As promised, that question about Newton's universal gravitational law. Alright, it comes out of a paper and it was a matric paper in 2015. So I know it's 10 years ago, but let's have a look if we can answer this one. Okay, so they do give you a diagram, and the diagram looks like this. They show you Earth and then around in an orbit, and the orbit looks like this. Alright, they show the moon orbiting Earth. And they do give us, now remember, always read your questions very accurately and look for what do they give you. Alright, so firstly, the moment that I see it's got to do with planets, and they ask me something about calculate the force, then we know it's Newton's gravitational law. And then we know we're going to use that formula. Alright, so now I'm going to read, and I see what they do give me is they say the mass of the moon, they do give me the mass of the moon, and the mass of the earth, yes, I have the mass of the earth, and they do give me the distance between the centers of those two, which is very important. And then I'm going to check and make sure, is it in kilogram and is it in meters? And it is. Alright, so now I'm ready to go. So the first question is, calculate the gravitational force of F between the Earth and Moon. Their centers a distant r apart. Alright, so we do have everything we need. And I'm going to use my formula, which states F, the force between gravitational force, equals G, my constant, the mass of the one, the mass of the other object, divided by the square of the radius or the distance between the two centers. Alright, so that's my formula. And remember, I get a mark for my formula. So just copy it from your data sheet, okay? Now I've already started my thing, and even if you don't know what to do, start with your formula and start putting in whatever you have. Alright, so now I'm going to have a look. Okay, we've got G as 6,67 times 10 to the minus 11. Then the mass of the earth, which they do give me, as 6 times 10 to the 24. Okay, that's a very rounded off number, but that's how they gave it to me. They do give me the mass of the moon as 7,35 times 10 to the 22 kilograms. And they did give me the distance. So I've got everything I can wish for. Times 10 to the 9. And don't forget the square. Alright, so I'm going to just calculate that. Let's see. Just remember all your brackets. Divided by 3,84 times 10 to the 9 square, and I do get my answer 1,9948, but I'm going to round off to 2 decimals, so it stays 99 times 10 to the 18th. What is my unit for force? It's Newton. Now let's make sure, do I have to give the direction as well? They say no, calculate, the gravitational force. If it would have said the magnitude of the gravitational force, I would have just said the magnitude and the unit. So now I do have to say that that force is an attraction force. So I'm going to say towards each other, or attraction force. Alright, then the second question is, name Newton's law that applied in question 7.1. Okay, so they just asked me to name the law, and we know the law is Newton's gravitational law. Alright, next question. Give a reason why the gravitational force extended by the Earth onto the Moon does not stay constant as the moon orbits Earth. So just 1 mark, you know, so there you actually have to think of it. That's not something you could have learned. But they do give me the orbit. And what do I see about that orbit? I see the orbit is elliptical, which means that the moon's distance from the Earth is going to change. And the moment the distance changes, here you can see it's much closer, then the force is going to change. So they say, give a reason why the force is going to change, and you say it's because it's got an elliptical orbit, so the distance is not always the same. Right, next question. Now listen to this. An asteroid with a mass here of 1/4 of the mass of the moon move at a distance of 2r. So not of a distance of r, but of a distance of 2 times r from Earth without using any values provided. Determine the force between the Earth and the asteroid in terms of force Earth-Moon. Alright, so there is what we were talking about when you're going to just use ratios. So I'm just going to take this away. So when we do our ratios, we're going to state now that was what we worked out to be the force between the Earth and the Moon. And we worked it out by F, got the F already, by G, mass of the Moon, mass of the Earth, divided by the distance squared between them. So that was that amount of 1,99 times 10 to the 18th Newton. Now they want me to just use the ratios and how it's going to change. So how am I going to do that? I'm going to say, okay, that new force, that I'm just going to say new, so you can know that that force is going to change because all of this is now changing. Now what am I going to do? We say, all right, keep G the same. The mass of Earth stays the same, but they say that that asteroid is only, what did they say? 1/4 of the mass of the Moon. So we've got now here 1/4 times the mass of the Moon, divided by, and it's now not on a distance r, but on a distance double r, 2 times r squared. So that is how the values is going to change. So what do I do? Just bring out those numbers to the front. So it's 1/4 divided by 2 squared, it is 4r squared. What do we see? That is exactly that. So I've got 1/4 divided by 4, so it is 1/4 times 1/4 F Earth Moon, and that becomes a 16th of Earth Moon. So we could now go and say, all right, so the new force between the asteroid and Earth is only going to be a 16th of that, what it was between Earth Moon. So I could now go and say, okay, Earth Moon was that, divide that by 16, and I've got a new value. But I remember we marked that here only that they have to go until saying it's going to change. It's becoming just 1/16 of the value that we did work out previously. So you see, it is not so difficult. Always read your question. You have to know what formula to use. It's on your data sheet. Copy it over on your form, on your paper. Start reading and see what you have. Don't make mistakes, and you're going to be fine. So, believe in yourself. You can do this.